physician, and I didn't change my mind for many, many years. After completing high school, I served in the army. I was in the unit that was on the border of Egypt during the 73 war, a horrible war, and I received the Army Commendation for heroic bravery in this war. Afterwards, I went to study medicine in Ben Gurion University, and actually, when I completed this study, I came to Hadassah, and I have been there as a hematologist for all these years. And in the past 19 years, I'm the head of the hematology department. I left Hadassah only for 2 years when I went for my research fellowship in Memorial Sloan Kettering in New York. As a young physician, I published, together with a psychologist of the department, a children's book, which we called There is Cancer at Home, because when you have any other disease, it's your disease, but cancer is the disease of the whole family. In Hadassah, I met my husband, who is Aryeh, who is the head of the internal medicine division in Hadassah, and we had our 3 daughters in the same hospital. Shir just completed her medical school in Hadassah, in the Hebrew University, and she's now a resident in a rehabilitation department in Hadassah. Our little daughter Bavat is a musician, and Or is an officer in the army. In 2015, she, as an officer, together with her driver and the radio man, they saw in the Egyptian border again 30 terrorists trying to pass the border to Israel, and they fought for a long time, all the 3 of them, against these terrorists, and they succeeded in avoiding their entrance to Israel. For her bravery, she received also a commendation from the head of staff, and I had the honor to give it to her. And as I told you before, I decided to study medicine when I was 3 years old. And when I came to the admission committee in the medical school and they asked me why I want to be a physician, I told them that I want to find a cure for cancer. And they all laughed. Probably they thought that, like the beauty queens that want to bring peace to the world. I've never been beauty queen, of course. I thought that I will overcome cancer, but recently we found a protein that causes cell death. We packed it into nanoparticles with measles against lymphoma cells, and we have very good preliminary results with this drug, and we hope to run very soon a clinical study. And because I was not busy enough, I decided to be the dean, and I'm the first woman dean in our faculty after 23 men. The Faculty of Medicine is composed of 5 schools. The School of Medicine with its military medicine track, the School of Pharmacy, and we have now also the School of Nursing, and in the School of Nursing we also have military track, the School of Occupational Therapy, and the Brown School of Public Health. We have a very strong research programs dealing with 5 disease-oriented translational research, cancer research, infectious and tropical diseases, metabolic diseases, neurodegenerative, and stem cell regenerative medicine. The faculty is affiliated to a few hospitals. First of all, Hadassah, which is like a partner of the faculty. We have Shaarei Tzedek, Kaplan, and all the 4 sick funds in Jerusalem. And we also have the Army that is also affiliated to our faculty. As I think that you all know, there is a huge revolution in medicine and healthcare. And for me, as a very long time physician, it seems that only the diseases remained unchanged. Taking an example from my world, multiple myeloma is the malignant cell of the immune cells, the plasma cells in the body, and it causes lesions in the bones. You can see here 2 skulls that looks just alike. The only difference is that one is from ancient Egypt, from 4000 before Christ, and the other one is from one of my patients from Jerusalem in 2017, looks just the same. But the patients are very different. The population is aging. There is a shift of focus from acute diseases to chronic diseases. There is expanding use of complementary and alternative medicine, and increasing patient involvement in treatment and decision-making. And in this area of medicine in the internet with Dr. Google, it always seems to me that even patients that come for first opinion, it's already second opinion because they've already visited Dr. Google. And many times patients will tell me, but Professor Ben Yehuda, in Google it's written this and that. How come you don't give me this medicine? And it's hard to explain. But if we are looking at it seriously, the result of this loss of paternity medicine, the medicine where the physician was the father or the mother, and when patient would ask, why do you do it, doctor? The doctor would answer, because I said so. And I think that in one hand, it's very good to have knowledgeable patients, and it's very good for the patients, but also for the physician. But on the other hand, the patients remain very lonely, sometimes in the worst time of their life. So what do they do? So it's written in Hebrew because it's taken from the holy books, and it says that when you have doubts, go to the rabbi and he'll tell you what to do. And I don't know how it's in Europe, but in Israel, many patients, especially with serious diseases, like diseases that I treat, malignant diseases, are going to consult with rabbis, some of them very wise people that will give very good advices, but some of them are using their power to achieve and to do bad things for patients. And the other things that happen during this time of loss of in medicine is that more and more people are looking for complementary and alternative medicine with the good and the bad of it, because we know that some of the complementary and alternative medicine might be very dangerous. And so in this era, one of the first decisions that I made as a dean is that it's high time to teach the students about complementary and alternative medicine, knowing the good things about it, but also how dangerous it might be for our patients. But the main revolution in medicine is what we call now precision medicine, or tailored medicine, a lot of names. And for me, the best way to understand what precision medicine is to define it as knowing and learning the variations between patients and finding what's unique to each and every patient. And again, if we are going to my world, and these are two patients with acute leukemia, cancer of the blood. They are both the same age. They both have the same high leukocytes, white blood cells, like every leukemic patient. They both have the same amount of platelets, the particles that clot the blood, which is very low and very characteristic of acute leukemia. Their bone marrow looks just alike. You can't differentiate between the two bone marrows. And they both have the diagnosis of acute myeloid leukemia. They both get chemotherapy. One patient is in complete remission. It's now 3 years that she's without evidence of disease, so she's cured from the leukemia. The other patient had no response, and we are still, after 3 years, 2 bone marrow transplantations, we're still fighting for their life. So what's the difference between these two patients? Why one achieved remission so easily and the other not? And the name of the game is that we are treating acute leukemia like one-size-fits-all medicine. And I'm very ashamed to show you this picture that could have been taken in 1973 or today in my department, because for all these years we are treating acute leukemia with the same 2 drugs. We call this protocol 7+3. But this is a traditional medicine, one-size-fits-all medicine. If these patients would have been patients with diabetes, they would all get the same pill to start with. And what will happen? 1/3 of them will benefit. 1/3 of them will not have any response. And 1/3 of them will have such adverse events that we will have to change the drug. The same if it was all these patients were patients with asthma, let's say. They would have get the same inhaler. Like I said before, it's one-size-fits-all medicine. And in other words, it's like a trial and error medicine. And it's now time that we are trying to change this paradigm from the transitioning form of one-size-fits-all to precision medicine. And what's precision medicine is in this aspect? You look at the whole body, you get a lot of information about the patient, and you try to give each and every patient the drug that fits him. Each patient benefits from individualized treatment. So coming back to my 2 patients, we discovered that the difference between these 2 patients was the fact that the one that did not respond to treatment had 3 bad proteins, abnormal proteins in her leukemic cells. And I'm very happy to tell you that about a year ago, one of the very, very talented researcher in our faculty, Non-Ben Area, published a paper in Cell, a very prestigious scientific journal, showing that he found a molecule, a small molecule, that attacks all 3 proteins. And I'm very proud to say that the New England Journal of Medicine, which is the most prestigious medical journal in the world, in the editorial, they wrote that this discovery is the first breakthrough in acute leukemia in 40 years. The FDA just now approved clinical trial, which will be run in Memorial Sloan Kettering in New York. And we hope that it will bring hope and maybe cure to my patient as well. So as I said before, precision medicine is knowing everything that is unique and different in a given patient. The clinical and tissue diagnosis, all kinds of genetic and what we call epigenetic changes, biomarkers, but not less important, environmental factors like diet. A lot is being investigated now about the microbiome. We know today that the content of the bacteria in our body dictates protein translation and dictates a lot of the diseases that we are suffering from. Collecting all this data will allow us to give precision diagnosis to the patient, precision therapy, and even more important, we'll be able to come to a healthy person when he's very young and tell him exactly what's his risk factors to develop this disease or another. In our faculty, we have everything to bring this type of medicine forward faster and more efficiently than anywhere else. First of all, because we have really the best translational medicine researchers that are studying and understanding the mechanism of diseases and how to prevent diseases. But there is another thing that we need for precision medicine, which is big data. In order to understand what's the difference between two patients, you need to have a lot of information about the disease that you are treating, meaning you have to have all the data you can achieve from as many patients as possible, which is something that the human mind, the human brain cannot cope with, but with machine learning and artificial intelligence, we know today how to take all these big data and make sense out of it. And for that, we need a good information technology, bioinformatics, but not less important, we need physicians that will understand the language, which will understand how to use all these big data in order to develop precision medicine to the patient. We also need drug development, of course, and in our university and the faculty, we have it all. We have the School of Public Health for the environmental factors and the diet. We have the hospitals, the health funds, the IDF, and for all the data on a lot of patients. And we have the Faculty of Law because we have a lot of ethical problems regarding collecting this data. We have a very strong computer science faculty, mathematics, and physics. But I would like to tell you what do we do in our faculty in order to have the proper physicians, future physicians, that will be able to get from all these data and all this digital medicine the best for their patients. So first of all, we need more MD, PhD students, more medical students that will be interested in understanding the pathophysiology, the molecular basis of each and every disease. Researchers, basic researchers, know a lot, and they are, of course, understand a lot. But the difference between a research physician and basic scientist is that we bring to the lab one of our patients. The drug that I just told you, the driven, what drove me into the lab to discover this protein and to find this drug was the fact that I had subset of lymphoma patients that I couldn't help. And when you bring to the lab one of your patients that were fighting for his life, it's different. And you bring not only knowledge, but also compassion and the drive to really find the solution. And I'm very proud to say that we started like 3 years ago with three students that took the MD PhD track, and we have now more than 60 students, exactly 65. The other thing that we need, can we move a little bit? You see the whole slide there, or?
They see the whole slide.
The whole slide, okay, so the other thing that we need is a computational medicine physician. Physicians that will talk the language with the computational scientists, because one of the problem, if you know, whenever I'm sitting with the computational scientists and they try to explain machine learning and artificial intelligence and how can you use bioinformatics to understand all these big data, they speak in a language that I don't understand. And they don't understand my language because I'm talking medicine. So I think that it's very important for us to have physicians that will speak the language of computation. And we did it. We created a special course that we call SAGOL, course for computational medicine. We chose the wisest of the wisest students in the first year, and we offered them to study, to have a combined degree in medicine and in computational science. I was very reluctant if they will be able to do it, but they completed the first year and they are amazing. They finished the last year with more than 90% marks both in medicine and in computational science. And talking with them and seeing their enthusiasm and the way that they already understand how they can use the power of computation and machine learning and the artificial intelligence for the patients is amazing. And the third course that we are just starting now is innovation and entrepreneurship. It's a very hard word for me to pronounce, but it's written so you can read it. And the idea is, again, that the bright young mind, when they first time encountered an unmet need in medicine, they have all kinds of ideas, and I want them to have the tools to develop new methods and new devices and so forth. So, taking all this together, we are building now the Center for Computational Medicine in our faculty, where we will use information from health funds, from the Army, from the faculty itself, from hospitals, and we'll take all this data to create a very big data, and then using machine learning and artificial intelligence will be able to do data integration. Now, in this center, there will be physicians, scientists, and this little one who is against the computer, he also have a white coat because he'll be either computational researcher or preferably computational physician. And the aim is to produce the precision drug for Noah. Why Noah? Because Noah is the most common name in Hebrew. I didn't know it, but when I had to create a name for the presentation, I learned it. So the idea is to have a building. This is a virtual picture, but this is a building with content, meaning we'll have 3 floors which will be center for education and leadership of computational medicine. We have 1 floor for data acquisition, patient samples and data. We have division, 2 floors as a division of bioinformatics and computational medicine, 2 floors for disease modeling and research center for translational computational medicine, and we have a therapy design and testing center where using animal models or even just cell lines in the tube from a specific patient in order to see which drug is most suitable for his or her disease. So probably there are some people in the audience telling themselves, what are she talking about? Everybody in the world is doing the same. But I have a few arguments why we. So one of the most powerful thing about our faculty is the closeness and the integration between hospital and faculty. It's a multidisciplinary campus. We have the medical school with the military track, pharmacy school, public health, occupational therapy, and nursing school. And we've already shown that this multidisciplinary collaboration brought to very important discoveries like the Exelon for dementia, like cell-free liquid diagnosis, like treatments of acute leukemia, as I told you before, the Doxil that helped giving a cytotoxic drug and saving the heart and so forth. We have academic excellence across disciplines in the university because precision medicine will not be only in the hands of physicians, and we have leading departments in computer science, economics, law, and etc. And there is the Jerusalem assets. First of all, the population of Jerusalem is very unique. We have 2 hospitals and 2 major HMOs that cover the entire diverse population. And we also have the good connection with the army. Jerusalem has a very strong high-tech industries. There is a national and municipal interest in developing these type of things in Jerusalem. And we have this affiliation to the universities and the between the universities and the hospital and so forth. But there is also one very important thing, and this is the Jerusalem population. You know, on the one hand, we have a village near Jerusalem with thousands of people, 3 families. It's like a heaven for genetic and environmental studies. And we have the very ultra-Orthodox Jews. You know that last clinic I had in my clinic, one of my patients, very religious one, she has 13 children, and she came with her friend who has 12 children. So I asked myself, I didn't ask them, what will happen if they want to take the kids to the zoo? But then I remember that they don't take the kids to the zoo. It's not kosher enough. But these huge families are also a way to study a very unique population as for the genetic background, but also as for the environmental background, because they eat the same. They have very similar way of life. And the fact of the matter is that many people from all over the world are coming here begging us to collaborate with us regarding this type of populations. And most importantly, we are already there. First of all, the university commitment. The president and the management of the university is totally committed to this project. We have proof of concept. We've already created Jerusalem Center for Personalized Medicine, where we collaborate between the two major hospitals in the city and the two major HMOs and the army. And we are already practicing this type of sharing data and using bioinformatics to understand the data. We have the new Sagol educational program that I just told you about in computational medicine. Lately, we recruited 7 computational medicine scientists, and we also have a very big success in precision medicine grants. So individual scientists together with physicians applied for the Israeli precision medicine grants, and 50% of the grants came to our faculty. We also have a very strong international advisory committee. Professor Eric Lander, who is the manager of the Broad Institute, the founder and the manager of the Broad Institute. Professor Aaron Chechanover from the Technion, who is a Nobel Prize winner. And though he's from another university, he decided to be part of it because he believed that if somebody can do it, we can do it. Professor Robert Weinberg from the MIT, and Professor Jean-Yves Delattre from France. So I talked a lot about how we need to have physicians that will be part of the digital medicine and the machine learning and the AI. And many times I'm being asked if the nurses and the doctors will be replaced by this artificial intelligence. And I also always tell them that the AI can't replace nurses and doctors, but it can make them better. And why not? Because I think that there will never be a computer that will be able to give compassion and empathy like we can do it. And sometimes when my students want to annoy me, they see me with a stethoscope, holding the hand of the patient, palpating his pulse and listening to the heartbeat. And they tell me, Ben Yehuda, you are outdated. There is an application on the cellular phone. You can come from far away and you can know everything about the heart of the patient. And I tell them that when I hold the hand of the patient and I'm putting the stethoscope on his heart, this is the time when I'm not just listening to the heartbeat and the murmurs, I'm listening to his heart. And so many times when I'm doing it, the patient tells me things that he didn't tell me before. I can look at his face and see he's worried. When I palpate his abdomen, I can see exactly where it hurts. No computer will be able to do it. And as I started before, just started my talk, I said that in the time of digital medicine, patients will need a small, not less, because they will be very lonely. And there is no speech with a written word in the internet. You can only talk with a person. So these are my 5 grandchildren. Erez, these are the twins, Eli and Neta. This is Nili. And this little one was born 4 days ago. And they are all already, I signed them from 2035 to 2039 to the Sagol track of computational medicine. Thank you.
Thank you to you, Dina, for this incredibly interesting lecture. It's now time for our listeners to ask for questions. Please write or raise your hand, and you can ask your questions. No, unmute. Okay, we will wait a few more minutes for a question. In English. Okay. Okay, Catherine is asking, Dina Catherine from France, she's asking how many centers of the same kind in Israel and in the world are?
So we're the first in Israel, and there is a beginning of awareness to build such a center in such centers in the state. I can tell you that Mount Sinai has one that was initiated only a few months ago, but the concept of this multidisciplinary center is something that is very unique, and the computational medicine track, I think that we are the first in the world.
We have another question, again from France. How much this project will cost?
I'm happy that you asked me this question.
It's Deborah question from Paris.
Thank you, Deborah. So as for the building, we're talking about around $39 million. We've already raised I have here a help from Ram Semo, but we've already raised some of this money. We're waiting for another $17 million. And the Hebrew University is committed for another $42.5 million. And as a research gift, we're talking about $17 million. And I have to say that we see that many donors are very interested in this subject. We have a lot of people that are willing to donate. But as I said before, we are still short of money to accomplish it all. I can tell you that we are going to build this building on a building that is also already exists. 3 floors are already exist, so we need like 7 other floors. And I think that that with your help and with the help of the other university friends, we are able to do it very quickly because everything is ready. We are ready to go. All the programs are ready, and we're really looking forward to start building the new floors.
We have another question from Eric Bernheim from Switzerland. Please, Eric, you can speak. We don't hear you. Maybe do you want to write it on the chat? Okay, in the meanwhile, we have another question from Roland Kluger. As you have a, so he's asking, as you have a professor from Paris, Salpêtrière, on your board, could we use to do some work in Paris? What is the priority? HR and or raising money? Which priority do you think is the best?
I think that we've already have collaborations with the French universities. I think that what we need now is more and more donations. As for collaboration, each and every researchers and physicians have the ability and to say, to be honest, scientists from all over the world are interested in collaborating with us. So this is not our problem. You know, from all the things that I did as Dean, the easiest thing for me to do was to recruit the advisory board. Everybody wanted it. I got answers in a few minutes. And so I think that more important for us is to raise money.
And I think the last question, do we have a deadline?
Yesterday.
Yesterday, yeah, 2 days ago. Okay, thank you very much to all of you, to Dina, of course, especially. It was a very interesting lecture.
Thank you.
And thank you to all. We'll have another webinar next month. You will receive the invitation soon. I hope to see you there. Thank you very much.
כמה היו? היו 43 איש. לא?